Hi students, in the last video we were discussed about the relation between term and positions of an arithmetic sequence. That is Tm minus Tn is equal to m minus n into d. The difference between any two terms of an arithmetic sequence is equal to the product of difference of position and the common difference. And one more relation we found from this equation is the difference between any two terms of an arithmetic sequence is always equal to the multiple of common difference. Now we are going to find out another general equation. So right now we are considering one question here, that is 2, 4, 6, 8. We need to find out the 20th term. Okay, so all of you know that this is an even number sequence. How we are going to find out the 20th term, T20? We know that this is the first term, that is 2. From 2 how many times? Starting from 2, how many times common difference need to add to get the 20th term? That is 19 times. That is 1 plus 19, that is 20. So 19 times the common difference need to add. Instead of adding, we can write 19 into d. I can rewrite this as T20 is equal to 2 plus 20 minus 1, that is 19 itself, into d. From here, I am going to find out the general equation for the nth term. Okay, here you can see f I am considering as first term and d as the common difference, Tn as the nth term and n as the position of this nth term. Okay, so instead of T20 I am writing the nth term. We are going to find out the equation for nth term, that is I am writing Tn equal to first term I am writing f, instead of 2 I am writing f, plus here you can see 20, the 20th term, so 20 minus 1 will come. So in the same way, if you are going to find out the nth term, then n minus 1 will come into d. So this is the general formula to find out the nth term of any arithmetic sequence. Okay, so if you want, you can find out the answer for this particular, that is T20 we can find out right now. T20 is equal to 2 plus 20 minus 1 into d. That is 2 plus 20 minus 1, 19. The common difference here it is 2. That is 2 plus 38. So the 20th term is 40. 20th term is 40. So we can use this formula to find out the nth term of any arithmetic sequence. Here we are going to discuss about algebraic form of arithmetic sequence. Before going to know about the algebraic form of arithmetic sequence, we need to know some basic things. That is, we need to know the algebraic form of multiples of natural numbers. So here, I wrote here the multiples of 2, that is 2, 4, 6, 8. All of you know that. And this is the algebraic form of multiples of 2, that is 2n. If you are putting n equal to 1, 2 into 1, 2 will come. If you are putting n equal to 2, 2 into 2, 4 will come. So in this way, you can construct all the terms from this general form. So we can consider multiples of 3. That is 3, 6, 9, 12. All of you know that. So the general form or algebraic form of multiples of 3 is 3n. That is, if you are putting n equal to 1, first term 3 will come. If you are putting n equal to 2, 3 into 2, 6 will come. So in this way, you can construct all the terms from this particular form. So this is the algebraic form. That is, in general, we can say that if you're putting if you're taking any number, any natural number, and if you're writing the multiples, that if you're taking 100, and if you're writing the multiples of 100, you can write the algebraic form as 100n. Okay, so this point we are taking this point to solve this type of arithmetic sequence. I wrote here the sequence as 7, 10, 13, 16. So first we need to find out the common difference. That is, the common difference is 3 here. That all of you know. So we are going to write the algebraic form of this particular arithmetic sequence. So first we are going to write the algebraic form of multiples of the common difference. First we are going to write the algebraic form of multiples of common difference. That is, here the common difference is 3. So the algebraic form of common difference, we can write it like this, 3n. Okay. Now, if you are putting n equal to 1, 3 into 1, 3, 3 into 1, 3 will come. So our first term is 7. So we need to add 4. Then only we get the first term as 7. Now we can check it. N equal to 2, if you are putting n equal to 2, 3 into 2, 6. 6 plus 4, 10 will come. If you are putting n equal to 3, 3 into 3, 9 plus 4, 13 will come. In this way, we can construct all the terms from this particular algebraic form. So this is the algebraic form of this arithmetic sequence. We can consider another example here. That is, here also we are going to find out the algebraic form. That is xn equal to, therefore we need to find out the common difference. That is, here the common difference is 4. I already told you, the first thing what we need to do is, we need to write the algebraic form of multiples of common difference. Okay. So the multiples of common difference, the common difference here it is 4. The multiples of algebraic form of multiples of 4 is 4n, that we need to write. And now we need to check the first term. Here the first term is 1. So if you are putting n equal to 1, 4 will come. We need the first term as 1. So we need to subtract 3. Then only we get the first term as 1. If you are putting n equal to 2, 4 into 2, 8. 8 minus 3, 5 will come. If you are putting n equal to 3, 4 into 3, 12 minus 3, 9 will come. So in this way we can construct all the terms from this general form. So this is the algebraic form of this particular sequence. So I conclude here that in any arithmetic sequence we can write as xn equal to an plus b, in the form of xn equal to an plus b, and here a and b are constant and a is the common difference itself. You can see here 4 and means 4 is the common difference. In this way a is the common difference. That is, this is the algebraic form or general form of any arithmetic sequence. Let us consider another problem here. You can see the 8th term of an arithmetic sequence is 12 and 12th term is 8. We need to find out the algebraic expression of this particular sequence. So we already studied that xn equal to an plus b. This is the general form of any arithmetic sequence. So first we need to find out the common difference. How we are going to find out the common difference? We can apply the equation between the two terms, that is Tm minus Tn is equal to m minus n into d. So here we can apply, it is given that 8th term is 12, that is, and 12th term is 8. So 8 minus Tm I am taking as 8 minus 12 equal to, the position of 8 is 12 minus 8 into d. That is 8 minus 12 is minus 4, 12 minus 8 is 4 into d. Then d is equal to minus 4 by 4 minus 1. So we got the common difference as minus 1. Now we need to find out the first term. Okay. How we are going to find out the first term? The first term, here you can see the 8th term is 12. So before we have 7 terms are there. So if you are finding out the right terms, we need to add. If you are finding out the left terms, we need to subtract. That all of you know. So here this is the 8th term is 12. We need to subtract because we need to find out the first term. So how many common difference we need to subtract? 7 common difference, because here you can see the 8th term is 12. We have 7 terms are in the back side, so we need to subtract 7 common difference. Instead of that, we can write this 7 into d, we can write, that is 12 minus 7 into minus 1. We got 12 plus 7, 19 will get. So this is our first term. 19 is our first term. Okay? 19 is our first term. So now we can substitute all of details here in this form. Then we will find out the algebraic expression. That is xn equal to. We already said that if we are writing the algebraic form of multiples of common difference. Here the common difference is minus 1. So we can write it as minus 1 into n first. Now we need to check it. We need to get the first term as 19. So if you are putting n equal to 1 minus 1 into 1 minus 1. So if you are adding 20 only, we will get the first term as 19. Okay. Now we can rewrite this as xn equal to 20 minus n. And n equal to 1, 2, 3, etc. Now we can check it here. If you are putting n equal to 120 minus 1, 19. Okay. That is here the common difference is minus 1, that is 18, 17 will come. Now if you are putting n equal to 2, 20 minus 2, that is 18 will come. If you are putting n equal to 3, 20 minus 3, 17 will come. So we can check it. If you are putting n equal to 12, 20 minus 12, 8 will come. In this way we can construct all the terms from this general form. So this is the algebraic expression of this arithmetic sequence. Let us discuss a new relation from arithmetic sequence. Here I written, you can see odd number of terms, and here it is even number of terms. We can consider the odd number of terms first. Here x minus d, x plus d are the terms. How many terms are here? 1, 2, 3. That is odd number of terms. Now we are going to add these terms, x minus d plus x d, x plus d. Then the sum is minus d and plus d cancelled. And x 3x are there, so 3x is the answer. That is 3 times the middle number. How middle number is x? The sum is 3x. So 3 times the middle number is the answer. Now if you are taking the average of this, that is 3x is the total sum and the total number of terms is 3, then the average is x will come. So if you are taking the average, the center number itself will come. So we can generalize this as if you are taking any odd number of terms, let us say n odd numbers if you are taking, then the sum is n times the middle number and the average is center number itself. Let us consider one example here. You can see here 1, 2, 3, 4, 5, that is odd number of terms. Now we can add these terms. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. And if you divide here, the sum is 15. Here the center number is 3. So 5 times the middle number. Here we have 5 terms. So 5 times the middle number is the answer here. And if you are taking the average, all of you know how to take the average, then we get the center number itself. Now let us take the even number of terms. if you are adding these terms x plus d plus x plus 2d plus x plus 3d. Okay, x 1 2 3 4 x are here, so 4x plus how many d are here? D 2d 3d plus 3d, that is 6d are here. I can rewrite this 4x plus 6d as 2 into 2x plus 3d. Again I can rewrite this as 2 into x plus d plus x plus 2d. That is, you can see here our center number is x plus d and x plus 2d. So here you can see the sum is 2 into x plus d into x plus 2d. That means the sum is always 2 times the sum of two middle numbers. So here in the even number of terms we have two numbers as a middle numbers. So the sum is 2 times the sum of two numbers, middle two numbers. Okay, and if you're taking the average, here I can write x plus d plus x plus 2d divided by how many terms? 1 2 3 4 terms are here. So the average is x plus d plus x plus 2d by 2. So if you are taking the average, then the center number average we are getting. Center number average we are getting, that is x plus d by x plus 2d by 2. Okay, we can just check one example here. How many terms are here? 1, 2, 3, 4. 4 terms are here. Now we can add these terms 1 plus 2 plus 3 plus 4. That is 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. That means our center numbers are 2 and 3. Okay. So here 2 plus 3 is 5. 5 into 2. 2 times of the center number of sum of two middle numbers. Okay. That is 10 we are getting. Now if you are taking the average, that is the sum is 10. Then the average, if you are taking 1, 2, 3, 4 terms are here. Then we are getting 5 by 2, that is 2.5. That is average of the middle two term itself. That is 2 plus 1, 3, 3. Sorry, 2 plus 3, 5, 5 by 2, 2.5 itself. Let us consider one problem here. You can see, right, 3 arithmetic sequences with 30 as a sum of the first 5 terms. That is, here it is given that the sum of 5 terms is 30 and number of terms is 5, that is odd number of terms. We already studied that is sum, total number of terms, and the sum is given, that is sum divided by total number of terms is equal to 6, that is 6 is the center number that we already studied. Okay, now we can construct arithmetic sequences by fixing the center number as 6. Now here we can take any number as common difference. That is, if I am taking 1 as the common difference, then 6 plus 1 is 7, 7 plus 1 8. Here we need to subtract, that is 6 minus 1 5 and 5 minus 1 4. If you are adding these 5 terms, we will get the sum 30. We can check it. 4 plus 5 9, 9 plus 6 15, 15 plus 7 22, 22 plus 8 30. Again we can construct the arithmetic sequence by fixing 6 as a center number. We can choose any number as the common difference. That is, if you are taking 2 as the common difference, then 6 plus 2 8, 8 plus 2 10. Here we need to subtract, that is 6 minus 2, that is 4 will come, 4 minus 2 2 will come. So 2 plus 4 6, 6 plus 6 12, 12 plus 8 20, 20 plus 10 30 is the sum. Again one more we can construct here. We need to fix the center number as 6 and we can take any number as the common difference. If you are taking the common difference as 5, then 6 plus 5 11, 11 plus 5 16. Here 6 minus 5 1, 1 minus 5 minus 4. Now if you are adding, we will get the sum as 30. That is 16 plus 11, that is 27, 27 plus 6, 33, 33 plus 1, 34, 34 plus minus 4. That is the sum 30 will come. In this way, we can construct arithmetic sequences. Let us consider another problem here. The first term of an arithmetic sequence is 1 and the sum of the first 4 terms is 100. Find the first 4 terms. Here it is given that the first term is 1 and the sum of first 4 terms is 100. So 100 minus 1, that is 99, will be the sum of second, third and fourth term. That is, these 3 terms we got the sum as 99. So we already studied that if we are having an odd number of terms, the sum is given 99 and the term is 1, 2, 3 are here. So sum divided by number of terms, we will get the center number. That is 33, we got the center number right now. Now here you can see the first term is 1, that is given. Third term is 33, that we found. Now you can see that starting from 1, how many times the common difference add to get 33? That is 1, 2 times we need to add. That means 2 into d we can write. Then we will get the term 33. So 2d equal to 33 minus 1, 32. D equal to, that is common difference is equal to 32 by 2, 60 as the common difference. Now we can add 1 plus 16, that is 17 will be the second term. 17 plus 16, 33 is the third term. And the fourth term is 33 plus 16, that is 49. This is the answer. Let us consider another example here. That is, write 2 arithmetic sequences with 100 as the sum of the first 4 terms. That is, here given sum is equal to 100 and even number of terms is given. That is 4. So we already studied total sum divided by number of terms is equal to the average of middle 2 terms. That is, 25 is the average of middle 2 terms. So the sum is 50 will come. The average is 25, then the sum of middle 2 terms will be 50. So we can fix the middle 2 term sum is 50 right now. That is, if I am considering 20 and 30, that is 20 plus 30, 50. Then the common difference you can see here, it is 10. So 30 plus 10, 40 will come. Here we need to subtract, then 10 will come. Now we can add these terms, that is 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, 100 is the sum. Now we can construct one more sequence here. We need to fix the center 2 numbers as sum of 2 numbers as 50. That is 10 plus 40 we can take it. Okay. So the common difference is 30 here. That is 40 plus 30 is 70. Now we need to subtract. So 10 minus 30, that is minus 20 will come. Now we can add all the positive numbers. First 70 plus 40, 110, 110 plus 10, 120, 120 plus minus 20, that is 100 will come. So in this way we can construct sequences. Let's consider one problem here. Prove that the arithmetic sequence with first term 1 by 3 and the common difference 1 by 6 contains all natural numbers. Here given the first term as 1 by 3 and the common difference is 1 by 6. First we need to find out the nth term. Then only we can say that we can find out natural numbers are existing or not. So all of you know how to find out the nth term. The equation to find out the nth term is Tn is equal to f plus n minus 1 into d that we already studied. So here first term is 1 by 3 plus n minus 1 into common difference is 1 by 6. So 1 by 3 plus n into 1 by 6 minus 1 by 6. 1 by 6 into 1 minus 1 by 6 will come. So we can solve this. 1 by 3 minus 1 by 6 plus n into 1 by 6. We can write like this. Here you can see, we can take the LCM as 6. So here 2 minus 1 will come plus n into 1, n by 6 we can write. That is 1 by 6 plus n by 6. That is 1 by 6 is common. We can take outside 1 by 6. 1 plus n. Okay, so this is our nth term. Now you can see here the nth term is 1 plus n by 6 also. We can write like this also. We can write 1 into 1 plus n will come divided by 6. Here you can see the denominator is 6. So if you want to get the natural numbers, we need to put multiples of 6 in the numerator. So here if you are putting n equal to 5 first, then Tn is equal to 1 plus 5 by 6, that is 6 by 6, 1 will come. If I am putting n equal to 11, then Tn is equal to 1 plus 11 by 6, that is 12 by 6, 2 will come. If I am putting n equal to 17, then Tn is equal to 1 plus 17 by 6, 18 by 6, 3 will come. That is the sequence 1, 2, 3, etc. We can find all the natural numbers. We can construct from this general form. Let us consider one problem here. The angles of a pentagon are in arithmetic sequence. Prove that its smallest angle is greater than 36. All of you know that what pentagon is. The 5 sides of a geometrical figure is called pentagon. Okay, and the equation to find out the sum of angles is equal to n minus 2 into 180. Here n equal to 5, then 5 minus 2 into 180, that is 3 into 180, 540 will get. That is sum of angle is 540. And we have 5 terms here. So sum divided by number of terms is the center number. That is 108 will be the center number. Now here the question is prove that its smallest angle is greater than 36. Now just consider 36 as the first term. And we can find the common difference right now. That is 36 plus how many times the common difference need to add to get 108? 2 times. That is 2 into d. We can write. Then we will get the term 108. Here 2d equal to 108 minus 36, 72 will come. That is d equal to 72 by 2, that is 36. Now we got the common difference 36. Now we can add 36 plus 36, we get the second term as 72. 72 plus 36 we got, here it is already 108. And 108 plus 36, that is 144. And 144 plus 36, this is 180 here. Here you can see 190 is coming. All of you know that the straight line is having the angle 180. Here the pentagon will be drawing like this. So we need to cut or join with another line. Here the straight line is forming only 180. So this condition is false. That is, a 36 will not be coming here. It is here, the smallest angle will not be coming as 36. It should be greater than 36. Let us consider another problem here. You can see write the integers in the arithmetic sequence 11 by 8, 14 by 8, 17 by 8. Do they form an arithmetic sequence? That is, it is given here the sequence as 11 by 8, 14 by 8 and 17 by 8. We need to check integers is coming in this sequence or not. That is, you can see here that 8 is in the denominator. That is, if multiples of 8 is coming in the numerator, then only we can say that integer is coming. So you can see here the multiples of 8 I have written here, and in the numerator the numbers are going like this 11, 14, 17. So proceeding like this, you can see the first multiple of 8 is 32. That is 32 by 8 we can write. Then the second multiple of 8 is 56 is coming. That is 56 by 8 we can write. And here one more 8 is also here, that we can write it like this. That is 32 by 8 is 4, 56 by 8 is 7, and this is 10. 80 by 8 is 10. That is, here you can see the common difference is 3. 3 is the common difference. Our question is, do they form an arithmetic sequence? Here clearly a common difference is existing, so we can say that this is an arithmetic sequence.